A choice made over 30 years ago has limited the performance of every AFM made since. That changes now. Introducing Vero, a next-generation AFM from Oxford Instruments Asylum research. It's the first AFM to use quadrature phase differential interferometry to measure the true vertical tip displacement, making AFM results more accurate and repeatable. Conventional AFMs can't directly measure tip displacement. Instead, they use the optical beam detection method to measure the angular deflection of the cantilever. The idea is simple. If the tip is displaced, the cantilever will bend. But other factors, like electrostatic forces, can bend the cantilever too, even when the tip isn't moving. So, this assumption that cantilever deflection represents tip displacement often fails and causes artifacts in AFM measurements. Vero's innovative QPDI technology directly measures the true vertical tip displacement. And because it's an interferometer, it's inherently calibrated by the wavelength of light. The cantilever will still bend in response to electrostatic forces, but cantilever bending that's not caused by tip displacement will not affect the QPDI signal. Vero QPDI makes this measurement with significantly lower noise than OBD. This enables researchers to measure materials with ultra-low piezoelectric response, like hafnia. Here, we see that Vero clearly resolves piezoelectric domains, while the signal is lost below the OBD noise floor. Vero QPDI also avoids crosstalk between vertical and in-plane tip forces. In this bismuth ferrite sample, QPDI measures uniform out-of-plane polarization, whereas the OBD image contains large crosstalk artifacts. Vero QPDI enables Vero to produce more accurate and repeatable results. Here, we see repeated measurements of the piezoelectric response of scandium aluminum nitride. While the OBD results are scattered with broad distributions, the Vero QPDI results are all tightly clustered in narrow distributions. In summary, Vero's patented QPDI technology enables the direct measurement of true vertical tip displacement. It makes this measurement with significantly lower noise, eliminates crosstalk, and is precisely calibrated. Taken together, these technological advances enable AFM measurements to be made with unrivaled accuracy and repeatability. Vero, AFM redefined. Contact us today to experience Vero.